The world that built your foot no longer exists, but the code is still running. Here's what it actually says. Greek foot, the mountain climber. Your second toe sticks out further than your big toe. You've spent years hiding it in sandals. Stop. That toe kept your ancestors alive on ground most people couldn't cross. Mountain communities in the Pyrenees, the Andes, and the Himalayan foothills are believed to show higher rates of this foot than lowland populations in the same countries. That distribution follows elevation, not culture. Here's what that longer toe actually does. On a narrow ledge, your foot sits with the ball of the foot on the edge. A longer second toe reaches further over that edge. More of your foot stays in contact with the surface, further forward. That reach prevents your weight from tipping back. On wet rock or uneven ground, that extra length is the difference between holding and slipping. A 2004 study compared athletes in balance and climbing sports to non-athletes. Those athletes were significantly more likely to have this configuration. Once you understand what the toe does on uneven ground, the numbers make sense. In sprinting and jumping, the story flips. All push-off force should exit through the big toe. Widest, strongest, best positioned for that job. When the second toe is longer, weight shifts there instead. The big toe gets bypassed. Less force per stride, more strain on structures not designed to handle it. Then there's the shoe. Standard athletic footwear is built for a foot where the big toe is longest. Your second toe gets compressed against the front every single day. Do that for 10 years and the joint curves permanently. Surgery to fix it. Built for mountain terrain. Slowly destroyed by equipment built for flat ground. That's why it kept your ancestors alive where others couldn't follow, and why the right shoe changes everything. Flat foot, the ground reader. Society looks at flat feet and sees a defect. Biology looks at flat feet and sees a sensor. Doctors spent decades handing out orthotics. Coaches told athletes to fix their arch before training. They were treating a mismatch as a malfunction, not the same thing. A University of Virginia survey tracked 509 runners told by doctors they needed arch support. 69% reported previous injuries going away after switching to minimal footwear. Knee pain, foot pain, hip pain, gone. The arch wasn't the problem. The shoe was. Harvard's Daniel Lieberman studied populations that have never worn shoes. Stronger foot musculature than shoe-wearing populations, regardless of arch height. Whether the foot was being used was the variable, not the shape. Your ancestors moved on ground that shifted with every step. Wet riverbanks, loose volcanic soil, sandy floodplains. More foot on the ground means more grip, more sensory information. High-arched feet are suspended above the surface. Your foot reads it. What it costs is modern ground. Concrete doesn't shift, nothing to read. The advantage disappears, and zero shock absorption appears instead. Your foot wasn't built wrong. The ground changed. And the most common foot on Earth was built for something that took 50,000 years to perfect. Egyptian foot, the migration survivor. Your toes taper from big to small, each one slightly shorter than the last. Half the people watching this have exactly that foot. Shoe companies built the entire industry around it. You've never had trouble finding shoes that fit. That's not luck. That's majority infrastructure. But here's what that foot actually is. Picture a group of early humans. East African savanna. Not sprinting, walking. 15 to 25 miles every day, following game that moved faster than they did. The foot that survived those distances wasn't the most powerful. It was the most efficient. The big toe handles push off. Widest. Strongest. Best positioned for forward force. Every stride loads it directly. Transfers cleanly. Single rail track. Maximum energy in one direction. No waste. The athletic profile is distance, running, cycling, swimming, rowing, thousands of identical repetitions. This is the foot that shows up in distance event winners. What it costs is sideways. The pressure line that makes forward movement efficient concentrates force on the big toe joint during lateral cuts. Over years on hard courts, hallux valgus develops. The big toe bends inward. The foot that crossed continents pays for being forced into angles it was never built for. Your ancestors didn't need to change direction fast, neither did their feet. The foot that comes next was built for one thing above everything else, and it shows in every millimeter of the structure. Germanic foot, the power hunter. Your big toe is significantly larger than the rest. The other four roughly equal, shorter, broader, squarer across the front. The whole foot looks built rather than tapered. It looks that way because every millimeter of it was. Picture a Norse hunter, Northern European winter, dense forest, frozen uneven ground, carrying a kill back to camp over uneven terrain. One misstep under that load means a broken ankle miles from shelter. That's not an athletic scenario, that's survival math. Germanic foot architecture gives up rotation rotational speed, in exchange for a base that doesn't collapse under extreme force. The dominant big toe anchors the inner load-bearing line. The 4 outer toes prevent lateral rolling. For any athlete producing maximum force from a fixed position, powerlifting, wrestling, shot put, rugby scrums, this is the foot that doesn't give way. Narrower feet pivot faster. Longer-toed feet drive further forward per stride. What it trades away is both. On a synthetic sprint track, maximum stability meets nothing to anchor against. You are not built to be first across the finish line. You're built to be the last one standing when everyone else's foundation gave out. One foot type ran empires on a completely different principle, not power. Endurance, underweight, Roman foot, the load carrier. You have this foot if your first 3 toes are roughly the same length. Square front edge, more shelf than staircase. 1 in 4 people. No dramatic origin story. No sports brand targeting it. Just the foot that kept the largest military empire in history moving. Roman legions covered 20 miles a day under loads up to 40 kilograms. Armor, weapons, entrenching tools, rations, day after day, months at a time. The foot that made that sustainable didn't generate maximum force. It distributed force across 3 equal points so that no single structure ever hit failure first. 3 equal contact points instead of 1. Stable in any direction. No single weak point. The athletic profile is weighted endurance. Rucking, strongman, loaded trail running, rowing. Disciplines where carrying something for a long time determines the outcome. Egyptian and Greek feet are single point systems. Under sustained load, that single point breaks. Roman foot spreads the work. What it costs is explosiveness. 3 equal points don't generate the same leverage as 1 long lever. In explosive sports, this foot gets outperformed every time. Evolution chose carrying capacity over speed. Your foot doesn't win the moment, it wins the distance. The last foot type doesn't fit any single profile. That turns out to be exactly the point. Celtic foot, the terrain adapter. Short big toe, second toe longer than the others. The remaining toes roughly equal in length before tapering at the end. Celtic foot is one of the rarest and most structurally complex configurations, a combination of Greek precision and Germanic stability that sounds like a compromise and works like a Swiss Army knife. Picture a Celtic coastal community. Same person fishes in the morning, farms on hillside terrain in the afternoon, hunts in forest by evening. Pure Greek foot excels on vertical terrain but becomes unstable under lateral loading. Pure Germanic foot is rock solid under weight but slow to pivot. Celtic foot covers the range that neither specialist handles alone. Research in Western Europe and the British Isles shows elevated rates in populations with genuinely mixed movement histories. The same demands that shaped the foot are still readable in where it shows up. Celtic-footed athletes appear consistently across field sports, racket sports, and trail events. Not the fastest, not the most stable under maximum load. Functional when 5 different demands hit in the same match. Elite sport rewards specialists. Celtic foot gets outperformed when one thing is demanded maximally, but most sport isn't played at the elite ceiling. At the level where doing 5 things adequately beats doing 1 thing brilliantly, you're already there. What your foot has always known. 6 configurations, 6 survival strategies, each one built for something specific, each one with a cost. Most athletes spend their careers working against their foot structure instead of reading it. The mismatch between your foot and the surface, the sport, or the shoe, that's the obstacle. Unlike the foot, that's something you can change. Your foot has been pointing towards something the whole time. You just hadn't looked down yet.